Okay, this is lesson 3, working with negative slope. So in the graphs you have worked with so far in this chapter, the line always went up from left to right. That is, the graphs all had a positive slope. So everything looked like this graph here, up to the right. And the number was always positive. And remember, m equals slope. If a graph, either for a direct linear relation or for a partial linear relation, goes down from left to right, like the graph over here, it has what we call a negative slope because it's going down. Okay? And your number that you're going to calculate should come out negative. So, for example, Josie's car has a full tank of gas of 40 liters. She knows that if she travels at a fairly constant speed, her car uses about 1 liter per 9 kilometers. So in A, what we're going to do is make a table of values to represent the amount of fuel in Josie's car after she has driven 0, 45, 90, and 135. And what we should see is the amount go down. B, we're going to draw a graph of the data, and we're going to determine should you connect the points on the graph, why or why not. C, we're going to calculate the slope of the line and what does it represent. And then D, explain why the slope is negative and about how far can Josie travel before running out of fuel. So A. So we're going to make a table here. Josie uses 1 liter of fuel for every 9 kilometers of driving. Calculate how much fuel Josie needs to drive 45. Now, what I kind of did to figure this one out is I went, okay, so for every 9 kilometers, we're going to use 1 liter. So if we drive 45, if we divide 45 by 9, you get 5. And what that represents is 5 liters used. Okay, because remember 9 kilometers per 1 liter. So 2 liters would be 18. 3 liters would be 27. 4 liters would be 36. And 5 liters would be 45. But there's kind of a way you can do it there if this over here is a little bit too confusing for you. So over that 45 kilometers, the fuel remaining in her tank will be 35. Okay. And then the next question is, so after 90, how much fuel is left? Well, if 45 kilometers uses 5, we can just use logic that 90 is double of 45, so we should burn 10 liters. And 40 minus 10 would mean there are 30 liters remaining. And after 135. So for 135, I figured out how many times 9 went into 35 or 135, and I got 15. And again, remember 9 kilometers per 1 liter. So 15 liters times 9 kilometers would get us back to that 135. So I divided them again to get 15. And 40 minus 15 is 25 liters remaining. So on our table, the distance driven is going to be the independent variable, and the fuel remaining is going to be the dependent, because the fuel remaining is dependent on how many kilometers you drive. And here again is our table. And you can see based on all of these that it goes down by 5. Okay, so now we go graph those points. So at 0 kilometers driven, there's 40. 45 kilometers, 35. 90 kilometers, 30. 135, 25. Okay, the points on the graph can be connected because the data is continuous. So the way to think about that is as you're driving, the fuel you lose is continuous, or else your car is not going to it's not going to run. So you can just imagine that yes, we have only have points for here, here, and here, and here, but the fuel is going to constantly go down like so. Okay, so that's what we call continuous. The amount of fuel remaining decreases proportionally, or the way to think about it is the same amount as the distance driven increases. Now, realistically, this is probably not true, but for our purposes, we're going to assume. Okay, C was to calculate the slope. So you can really take any set of points you want. And they chose 30 and 90 and 40 and 0. So they went here and here. So your run of 90, rise of 10. Okay? Now, what we have to be aware here is the negative. So they have the negative in the equation, but what I would be okay with is if you just calculate the slope, so 10 over 90, and you're going to end up with 0.11. But if you want, instead of seeing this as a drop in 10 and positive over 90, what you can do is just go 10 divided by 90 and know that it's decreasing. So just add the negative. I'm okay with you doing that. And what this represents is the amount of fuel used per kilometer of driving. So you are effectively losing or using 0.11 liters per 1 kilometer. Okay, so for D, the slope is negative because the amount of fuel in the tank is decreasing as the distance driven increases. So if you want to look at the graph here again, it's going down 10, even though you're going increasing 90 kilometers. Okay. And again, if you just want to calculate the number and add the negative in yourself, that's fine too. You don't have to show it like this. Okay. E. It says about how far can Josie travel before running out of fuel. And what that would require is we'd have to extrapolate by extending the line to reach 0 liters. And unfortunately, our graph doesn't show that. So if you extended this, what they're saying is, can you predict? And this is how, in some of your cars, it will say how many liters of fuel are remaining. It's kind of the same idea, right? It's kind of predicting how much you're going to have left. Okay. So now we don't have any numbers for this, unfortunately. So what they are saying is that this would hit 370 kilometers until the fuel is gone. Now there is an alternative solution. You can use what is called proportional reasoning. So let X represents the distance Josie can drive on a full tank. She uses 9 kilometers, uses 1 liter of fuel for every 9 kilometers, and there are 40 liters of fuel in her car. So what you can do is set up the following. If you can go 9 kilometers per 1 liter, then how many kilometers can you go per 40? And what you do with proportional reasoning is make sure you got the same units top and bottom. So I got 9 kilometers, X amount of kilometers. 1 liter, 40 liters. Then once you have that set up properly, you can just remove the units. If it confuses you, you now have 9 over 1 equals X over 40. And from here, we can just cross multiply. So 40 up here, 1 up here. So what you end up with is 40 times 9. So you can kind of skip past this part here. 40 times 9 equals 1 times X. So you just end up with X. And 40 times 9 is 360. So Josie can travel about 360 kilometers before running out of fuel. And based on our graph, the extrapolation predicted was 370. But again, we didn't really have a proper graph to do so. Okay. Note, using proportional reasoning is usually more accurate than extrapolation. Obviously, you could see we were off a little bit because the graph is too small and the drawn line is too thick to calculate the exact value. So what they're saying is, like, if you had a proper graph here, you're counting on yourself to make a proper line and that it hit the right spot, right? So it's actually better to use proportional reasoning and set these two up. And again, just remember the units are the same and cross multiply from there. And that is the end of lesson 3, working with negative slope. Part 2 will have the build your skills.